Audio manipulation. Post-processing effects are possible on digital images, videos, and sounds, because we can transform the bits that encode them. These bits are numeric values and therefore can be altered using algorithms. This is a digitized sound of a hand clap, represented as the following digital sound wave. How would we represent the sound when it echoes? Since an echo is merely a sound that has bounced off of a surface and is reheard, the sound repeats. Therefore, to simulate an echo, the digitized sound wave should repeat. The same digital sound wave is simply copied. The digital sound wave is represented in binary values. For ease of demonstration, let's convert these binary values to decimal. 3, 1, 2, 4, 4, 5. How might an echo look in terms of the values encoded by the digital representation? We took the value for the hand clap sound wave and duplicated it 5 times to make an echo. Other post-processing effects like noise removal, auto-tuning, etc. are more complex. If you took all the values in a digitally encoded audio file and reversed their order, that would be similar to backmasking. 3, 1, 2, 4, 4, 5 reversed is 5, 4, 4, 2, 1, 3. The sound wave is recorded backward, but is meant to be played forward. To recap, audio manipulation. Post-processing effects are possible on digital images, videos, and sounds because we can transform the bits that encode them. To create an echo, take the binary values in a digitally encoded audio file and repeat them. To create backmasking, take the binary values in a digitally encoded audio file and reverse them.